To post a little video that will help you with a missing quiz, drawing tilted squares. Here's what you're going to need. You're going to need to have finished this assignment and to have recognized the pattern. You're going to need to know some perfect squares. If you know this pattern and these perfect squares, we should be able to finish the assignment. So I'm just going to go through my whole thought process here. Draw a square with an area of 45 square units. So first I'm just going to think about that. I'm just going to draw a quick square of any size so I can think about this. The area is 45 square units. What number times itself equals 45? Well, my multiplication tables tell me that there isn't an exact answer. So that means I'm going to have to come up with a tilted square in order to get a perfect result. So now what I want to do is I want to use this pattern. Right? I'm going to draw a picture just like this one, but I'm going to relabel it for this specific instance I'm looking at. The pattern is that the two smaller square areas will always add to the largest square area. So that's happening here. The two smaller square areas will add to the larger square area. So again, I'm just doing an estimation here. It doesn't have to be a beautiful picture. A nice right triangle. I'm going to stick some squares on the ends here. Remember, I've already decided that my square must be a tilted square because there's not a perfect whole number that would multiply together to make 45. If you need some reminder, 45 is not a number on this list, so it's not a perfect square. So what I know is that this is going to have to create a tilted square with an area of 45 units. I'm looking for two perfect squares that would sum to 45. So go ahead and pause the video, look down this list, come up with two numbers that add to 45. Hopefully you paused and came up with your solution. If I use the numbers 36 and 9, these will add together exactly to be 45. I am almost ready to create my final answer. I just need to do a little work here. The side length of a square with 9 square units would be 3 units long, and a side length of a square with 36 square units would be 6 units long. These two counting numbers now tell me how to create this square. I'm going to base it on this side length. If I make a vertex and count down 3 blocks and then go over 6 and make another vertex, I will have one side of my tilted square. So I'm going to use these numbers of 3 and 6 now in my workspace. I'm going to make a vertex anywhere. I'm going to count down 1, 2, 3, then turn 90 degrees and count 6. 1, 2, 3, 4, 5, 6. Here's my other vertex. If I want to keep going, I count 1, 2, 3, and then up 1, 2, 3, 4, 5, 6. And again, 1, 2, 3, 1, 2, 3, 4, 5, 6. Connecting these 4 vertices will give me a perfect square whose area is 45 square units. If I wanted nicer lines, I could use a ruler. So 3 down, 6 across are the counting values I will use to create a square with an area of 45 square units. Here's a problem similar to the second half. Draw a segment with an exact length of square root of 50. Well, I know that if I have any old square that's labeled with an area of 50, that its side length would be the square root of 50. So similar to the assignment I just did above, where I was trying to create a square with an area of 45, I now know that I need to create a square with an area of 50. And once I do, I know its side length would be the square root of 50. So once again, I think about this 3 square diagram. I know that I'm aiming for 50 in this box. What you'll note in a moment is that my diagram is a little wonky because when you look down this list, there's only one way to get to 50, right, with perfect squares, and that's by repeating the number 25. So although my picture looks disastrous, one of these squares must be 25. The other square, even though my picture doesn't show it, must also be 25. The two smaller squares are adding to be the sum of the bigger square. So I look for side lengths again. I'll put in some orange here. This side length will have to be 5 because 5 times 5 is 25. This side length, although it looks smaller in my picture, it won't be when I actually count it out, must also be 5. I'm going to get the correct segment by picking a vertex, counting down 5 and over 5, another vertex. This line between the 2 points will be the square root of 50. Now I make that happen. Here's a vertex. I count down 5. 1, 2, 3, 4, 5. I count across 1, 2, 3, 4, 5. There's my other vertex. This line segment is one side of a square that would hold 50 square units, so I know that this one length is the square root of 50. I hope you found that helpful. Good luck finishing.